alkane. Now, last part of this chapter is chemical properties of haloarene. It is electrophilic substitution reaction shown by the haloarenes. Chemical properties of haloarenes. To explain it, first you explain what is that? Resonance. You have done in previous class. Chlorobenzene is positive mesomeric effect because of the lone pair is being withdrawn inside the benzene ring. Delocalization of pi bond takes place, and what it is the negative 1, 2, 3 and positive. Now finally again there is resonance, and then this pi bond is shifting to this point, and then this pi bond is here, double bond, it is the positive charge. Now next time this pi bond will be here, and this is what finally it is here and getting back. Finally we get chlorobenzene. So dear students, here structure 1, 2, 3, 4 and what is that? 5. These three are known as what is that? Intermediate, which is very reactive size. One point is to be observed here. That kind of molecules gives positive mesomeric positive resonating effect, and that effect produce always ortho and para product, not meta. Why? Because of electrophile will replace the hydrogen from ortho and para. Again it is the ortho. Ortho has 2 sides and para has 1. So electron density is very much visible at ortho as well as para position. So chlorobenzene, bromobenzene, phenol, aniline, anisole, phenitol, all aniline, phenol, chlorobenzene, all undergo positive mesomeric effect. This was the part of the 11th class or positive resonating effects. They always produce 2 products. One is the ortho and another is the para. But for your kind information, para is always major and ortho is always what? Minor. Anyone can tell me why para is major? Because of, yes, because of more the symmetry, more the stability and lack of steric hindrance. But ortho is the minor because of 2 bulkier groups are very close, they repel to each other. It is known as steric hindrance in general form. It was also the part of the 11th class. What is steric hindrance? Repulsion due to bulkier groups near or adjacent point. Therefore, see all these structures and you come to conclude that whenever chlorobenzene undergo electrophilic substitution reaction to produce 2 products, one is the ortho and another is the para. Para is the major, reason behind it is more symmetry, more stability and no steric hindrance, but ortho is the minor because of symmetry nahi hai, and second is the repulsion ho jati hai. As a result, ऐसे सारे groups, these are known as ortho and para directing in nature. Let us discuss important reactions categorically to be explained under this parameter is called as chemical properties of the haloarenes, that is electrophilic substitution reactions. With the help of the electrophiles, chlorobenzene very much exhibits following important reaction. First is the halogenation. See, try to understand, either you can say chlorination or bromination, both have nearly same phase of the reaction. Most probably it forms 2 products. One is chlorobenzene whenever undergo chlorination in presence of FeCl3 in dark condition, then we replace one as from this point and this point. To balance this reaction, take twice HCl. One is the para-chloro and other is the ortho-chloro. 1,2 dichlorobenzene and 1,4 dichlorobenzene. So it is the ortho and what is that? Para ortho and para. What is that? Dichlorobenzene. It is the major because of, it is the minor, change the name, it is the para and it is the ortho. So it is the minor and this is called as, what is that? Major product. Second is the nitration. Dear students, whenever chlorobenzene undergo nitration, you take nitrating mixture. This is the HNO3 with H2SO4. So once you open the structure of nitric acid, which is delta negative, it is delta positive. This NO2 act as electrophiles. You take two molecules, H and H, two molecules, water lost. Water is to be lost due to the dehydrating agent. Sulfuric acid act as a concentrated sulfuric acid act as a dehydrating agent to replace two molecules of water. Therefore, it forms. It is the 1-chloro-2-nitrobenzene and 1-chloro-4-nitrobenzene or 1-chloro-2-nitrobenzene, which is minor and which is major. Same way, apposite condition, which is the minor, and the students, it is the major products. So IPAC name takes alphabetically. One stands for C, comes before N. 1, 2, either you proceed clockwise or you proceed anti-clockwise. Para is only 1. 1, 2, 3, 4. 1-chloro-4-nitrobenzene and 1-chloro-2-nitrobenzene. So another very important electrophilic substitution reaction of chlorobenzene is the nitration, which is over. Next is the sulfonation. The third is the sulfonation. You take in presence of the fuming or concentrated sulfuric acid, which is the concentrated H2SO4. So dear student, here HOSO3H. Take two molecules to balance this reaction. Replace the hydrogen from ortho and para. You take two molecules, water are lost. Anyone can tell me the IPAC nomenclature of this? Para pe sulfonic acid and here ortho pe sulfonic acid. SO3H, which is the 1, 2, 3 and 4. 4-chlorobenzene, what acid? Sulfonic acid, and it is the 2-chlorobenzene, what acid? Sulfonic acid. It is the minor and this one is the obviously major. So nitration reaction gives two very important products. That is what it is. The sulfonic acid is seen here in the preference order out of various functional groups taken to be 1, 2, 3, 4. 4-chlorobenzene sulfonic acid and 2-chlorobenzene sulfonic acid. It is a mixture of isomers of ortho and para-chlorobenzene sulfonic acid. Now last is the important for your CBSE paper, which is the Friedel-Crafts reaction. Friedel-Crafts reaction. It is of two types. Friedel-Crafts alkylation. Once you add the alkyl halide, it is called alkylation. And once you add the acyl halide, acylation. That could be in presence of acetyl chloride or ethanoyl chloride as well as acetic anhydride. Products will remain same. So you take chlorobenzene, then CS3Cl in presence of anhydrous AlCl3, Friedel-Crafts used. Lewis acid, which is electron deficient, that will pull the chlorine to that side. It becomes the positive charge and becomes the electrophiles. Right? So here it is the like this CS3Cl plus AlCl3. Mechanism of this reaction is CS3 positive charge plus AlCl4 negative charge. This is the mechanism. So what the product formed here? take two molecules, 2 times, replace twice HCl, one H from this point, another H from this point. Now this is called as 1 chloro 2-methyl benzene and 1 chloro 4-methyl benzene. One is the minor and other is the major product. Now last is the Friedel-Crafts acylation. Friedel-Crafts acylation. You take chlorobenzene, Cl, C double bond O, CS3 in presence of anhydrous AlCl3. Replace the hydrogen from H and H. Take 2 molecules, twice HCl out. Anyone can tell me the IPAC name of this compound? C double bond O CS3 plus chloro is there, C double bond O CS3. This is what it is the. So see, 2 chloroacetophenone, 1, 2, 3, 4 chloroacetophenone. So this is the 2 chloroacetophenone, and this is the 4 chloroacetophenone. It is the 1, 2, 3 and 4 because of the ketonic group. Same reaction can take place in presence of acetic anhydride. Product will remain same. So be very careful in paper. Examiner used to put like CS3CO whole twice O AlCl3, which is the acetic anhydride. So once you open this structure, CS3 C double bond O C double bond O CS3. Take 2 molecules, hydrogen and the hydrogen. Then this is called as 2 times CS3 COOH. Product will remain same. One is called as this and one is called as this. So Friedel-Crafts acylation takes place in presence of ethanoyl chloride or acetyl chloride as well as acetic anhydride. Product will remain same as this is known as Friedel-Crafts alkylation as well as acylation. These are very useful in getting conversions in the final CBSE paper. So once you have command over all the reactions, then organic is like mathematics and it will fetch your very good marks in the final paper because there is no chance for the deduction of marks. When you prepare preparation properties, conversions, you are supposed to command over the conversions in the organic reactions. So this is my request to solve all the questions from the exercise 10.19. Try to solve all these questions, that is conversions. 20 questions are given in your NCERT, that is your textbook, and it will have mastery over this chapter. This is all about haloalkane and haloarenes except one thing. I try to wind up my class by taking, you see, how to increase the nucleophilic substitution reaction of the chlorobenzene. Chlorobenzene, no doubt, are very prone, very comfortable in providing, you see, electrophilic substitution reaction. But it is very difficult for the chlorobenzene to go for nucleophilic substitution reaction. Why? See, chlorobenzenes, or you can say aryl halides, are extremely very less reactive towards nucleophilic substitution reaction. Why? I give you, see, one thing. Flow sheet is like RX plus NaOH aqueous. So see here, it's very fast reaction, ROH plus NaX, very fast, because of chlorine or bromine is highly electronegative, and this is positive and this is positive and this is the, so this nucleophile will easily attack to this point and reaction is very fast. But if I say chlorobenzene and same condition, NaOH in aqueous state, then no reaction is possible. Why? That is my question. When chlorobenzene is subjected to hydrolysis, what the product formed? Hydrolysis, I mean to say alkaline hydrolysis. That hydrolysis takes place with the help of aqueous NaOH or KOH. Then there is no reaction. But alkyl halides, wherever they undergo, they easily form alcohol. But not chlorobenzene easily form phenol. Why? The reason behind is, so see the parameters to explain this. First of all, chlorobenzene undergo resonance to form partial double bond character in between carbon and chlorine. As such, the double bond is formed here. It is difficult to break by the nucleophile. So more the bond order, more the bond dissociation energy. It is difficult to break the nucleophile and replace the chlorine. That is not a very easy job, because of double bond is formed, and that rate goes to what is that? That rate goes to resonance. Second factor is chlorobenzene. What kind of hybridization? It is sp2. But if I say alkyl halide, what kind of hybridization? sp3. It is simple to predict the hybridization in any organic molecule. If you are getting 4 sigma, single bond sigma, sp3. If you are getting 3 sigma, sp2. If you are getting 2 sigma, sp. So more the S character, more the electronegativity, more firmly the bond held together. It is difficult by the nucleophile to break the bond. As such, it has sp2 hybridization. So what is the S character here? 33%. But here what is the S character here? 25%. So more the S character, more the electronegativity. So sp has more electronegative than sp2, and then what is there? sp3. So it is more electro what? Negative element here. So as such, this chlorobenzene is difficult to proceed nucleophilic substitution reaction. Next factor is, it has 169 bond length because of double bond, but RCH2X has the bond length 177 picometer. 1 picometer is 10 to the power minus 12 meter. So more the bond length, lesser the bond dissociation energy, and it is difficult by the nucleophile to break this aliphatic series. But dear students, it's difficult to break by the nucleophile because its bond length is very less, and it is due to what? Double bond character. Double bond is due to what? Resonance. Resonance is due to delocalization of the electron. And then D is the phenyl carbocation is less stabilized by the resonance. So it is not stabilized by the resonance. So, and last but not least is the, you see, anyone can tell me any other point? Most probably is due to the repulsion, because of chlorobenzene saying I am rich of electrons, and any NaOH or KOH, here is the nucleophile, it is also the rich of electron because of the benzene itself. A pi bond, there is crowd of the pi bond, so that is very stable because of the resonance, as well as pi bond gives the electron maximum density. And here, no doubt, electrons are there. But here it is the minus, it is again the rich of electron. So there is possibility of what is there? Repulsion. These all facts prove that chlorobenzene are extremely less reactive towards nucleophilic substitution reaction, but they are very prone, they are very comfortable in giving, they are very excited in giving electrophilic substitution reaction, because of electrophile will be happier to replace the hydrogen from ortho and para, because chlorobenzene is not the meta-directing. Meta-directing categorically are negative mesomeric or negative resonating effect, that is are benzaldehyde, benzoic acid, benzene sulfonic acid, and nitrobenzene are only the meta-directing groups. These are deactivating groups. But chlorobenzene, bromobenzene, phenol, aniline are highly activating group, and they show positive mesomeric or positive resonating effect. In that way, two products are formed, ortho and para. So these all facts prove that chlorobenzenes are not very easy to give nucleophilic substitution reaction. Then what is the parameter, what the yardstick in the hand of the scientist or chemist to accelerate the rate of reaction, but under certain special experimental conditions? Dear students, what the experimental conditions are there? You can see how to replace chlorine from chlorobenzene. So first is, once chlorobenzene form phenol by getting aqueous NaOH or KOH, reaction is possible, but under certain conditions, 623 Kelvin and 300 atmospheric pressure, that was given by the Dowd, so it is known as Dowd process. In the next unit, we'll have a discussion how to prepare phenol from chlorobenzene. Unless and until if you don't provide these conditions, 623 Kelvin and 300 atmospheric pressure, then the reaction is not feasible. Therefore, you have to apply the experimental conditions which are relatively very uncommon. But as such, then phenol is formed. Otherwise, if you don't write this condition and you write this answer, then your answer will be incorrect. But if you provide these conditions, then your answer is correct. So, then the second is how to increase the reactivity of chlorobenzene towards the nucleophilic substitution reaction by inculcating, by enhancing, by introducing negative inductive effects. And you remember in 11th class, nitro has the maximum negative inductive effect. More you inculcation, more you include NO2 group, more you increase the rate of reactivity towards nucleophilic substitution reaction. So you have the parameter to increase the rate of reactivity by introducing -I effects, electron withdrawing groups. And out of all these groups, nitro has the maximum electron withdrawing groups. As such, it when treated with aqueous NaOH at 468 Kelvin, if I am correct, then this is the Na and this Cl is out here, NaCl, then it is the 4-nitrophenol is formed. Further you increase the reactivity, right? Then you introduce 2-nitro group here. It is the aqueous NaOH, then only 443 Kelvin, I think, 443 and 368 Kelvin. Then easily reaction takes place, chlorine is easily replaced because of you inculcating negative inductive effect. 2,4 dinitrophenol, and the last is the, you can say, finally not more than 3 NO2 can be introduced in chlorobenzene. And then if you want to replace the chlorobenzene, this is the nitro, ortho 2 point, left hand side as well as right hand side, and then aqueous NaOH, simply you warm it, simply you heat, then it forms NaCl is out, then it is the OH. Anyone can tell me the IPAC nomenclature of this compound? This is the common name is called as what acid? Picric acid, but IPAC system 2,4,6 trinitrophenol. It is such an acid which is very strongest acid in aromatic compound, although it does not contain any carboxylic group, but it is considered as one of the very strong acid because of more the negative inductive effect, more electron withdrawing tendency, higher the acidic character. So picric acid, or you take one from either this point, one is always here because it is the functional groups, to this or either this or this. 1, 2, 3, 4, 5 and what is that? 6. 2 nitro, 4 nitro and 6 nitro. Therefore 2,4,6 trinitrophenol, and commonly it is known as picric acid. So the way we come to conclude how to increase the reactivity of haloarenes, it is by introducing negative inductive effects. Nitro has the maximum negative inductive effect. Therefore, you introduce the nitro from this and this, 2 and 4, and finally 3 point there you have introduced NO2 group more easily, more comfortable the experimental conditions. Initially it was at high temperature, then at mild, and then low temperature. Simply it is warmed and the reaction takes place. This is all about. You just go through all the questions of your textbook, try to solve every question from the haloalkane and haloarenes, and then you will be mastery over this content. Go through preparation properties, physical properties, chemical properties and all. Just to go through all that reactions and try to write more and more. More to practice the reactions, more mastery over the content. Because you know practice makes a man perfect. Thank you very much. Have a nice day to all of you. God bless you. Bye.